Welcome back, everybody. Patrick here, moving on to the next question. So we have this diagram over here, and it has a point P, this point, and this point has coordinates 8, 5, and 7. We have to determine the magnitude of vector FC, so from here to here, and then we have to write an equation for the plane containing the points P, B, C, and D. P, B, C, and D. So let's start off by labeling this point here. So P, we know that this point has coordinates what? 8, 5, and 7. And since we know the coordinates of this point here, P, notice how this is a rectangular prism on the XYZ plane. We can label all the other points. Whenever I'm given a question like this, a rectangular prism and a point is given, first thing I like to label is always the intercepts. So notice the intercepts are happening at point C, that there is the y-intercept, point E is the x-intercept, and then point A is the z-intercept. So let's start off with this point C. Because it's going to be a y-intercept, we know that the values for x and z are going to be 0. What about the point for y though? What is it going to be? Well, notice that this face of the rectangular prism, so P, B, C, and D, notice that all of the y values on that face is going to be the same. And since point P has a y value of 5, then we know this is going to have a value of 5 as well for the y value. Right? So we know the y-intercept is happening at 5. So if you can see on this y-axis, this face that's sort of sticking out, all of the points have a y value of 5. Now, what about this point here, E? Well, notice it's the x-intercept. So we know that the y value is going to be 0 and the z value is going to be 0. What's the x value going to be? Well, notice now that this face of the rectangular prism, E, D, P, and F, are all going to have the same x value because it's a face that's sort of sticking out of that x-axis. And since we know P has a x value of 8, we know that this point E is going to have an x value of 8 as well. As well as points D and F, they're going to have x values of 8 as well because they're on that same face, but we will get to those later. And then finally point A, notice that is a z-intercept. So we know point A is going to have x values and y values of 0. What's the z value going to be? Well, notice that the face, the top face of this rectangular prism, A, F, P, and B, they're all going to have the same z value because it's a face that's sort of sticking out of the z-axis. Right? So they all have the same z value. Since point P has a z value of 7, point A is going to have a z value of 7 as well. Right, so we got the intercepts labeled, C, E, and A. Now we could label all the other points. So let's start off with point D. Notice that point D here is on the XY plane. And any point on the XY plane, we know that the Z value is 0. Right? Z value is 0 over here for this entire XY plane. So we know that this point D is going to have a z value of 0 for sure. Now what about the x and y values? Well, notice that point D is going to have the same x value as point E, right? The x value there is going to be the same. Point E has an x value of 8, means point D is going to have an x value of 8 as well. And then notice that point D will have the same y value as C, right? Because this line is sort of sticking out from that y-axis. So anything along this line here is going to have the same y value of 5. So we know point D, since it's on that line, it's going to have a y value of 5 as well. So this point D here is 8, 5, and 0. What about this point B here? Well, notice point B is on the YZ plane, right? So the X values are 0 for anything on the YZ plane. So we know that the X value of B is going to be 0. We know that the Y value of B is going to be the same Y value as C. So we know it's going to be 5. And then the Z value is going to be the same here. So it's going to have the same Z value as A, which is 7. And then finally this point F. Notice point F is on the XZ plane. And any points on this XZ plane, the Y value is 0. Always. So what's going to be the X and Z value for F? Well, notice that F is going to have the same Z value as A. We said that all of these points on this top face of the rectangular prism are all going to have the same Z value, which is 7. Point F is on that face. Well, notice that point F is also going to have the same X value as E, which is 8. So we know this point is going to be 8, 0, and 7. So notice that we were able to take this point P, which was on the outermost corner of this rectangular prism, and then with this point we were able to label all the other points, starting off with the intercepts, and then just working our way through the XY plane, through the YZ plane, and then through the XZ plane. So now that we have all these points, we can go into answering these questions. So part A, we have to determine the magnitude of vector FC. Well, notice FC is going to be a vector from point F, then it's going to have its head at point C. So if I draw a vector right through there. And how do we find the magnitude of a vector? Well, we just take the square root. Let me erase this actually. So the magnitude of FC, we just take the square root of the difference in the x coordinates, the y coordinates, the z coordinates. So what's the difference in the x coordinates between F and C? Well, 8 minus 0. And then we're going to square that. Then we're going to take the difference between the y values, so 0 minus 5, square that, and then 7 minus 0, square that. We could have also rearranged this and did 0 minus 8, 5 minus 0, 0 minus 7. It doesn't matter because when you square it, it's going to turn positive anyway. So what do we get here? Well, 8 minus 0 squared, that's 64. Negative 5 squared, that's 25. And then 7 minus 0 squared is 49. So when we add up all these, what do we get? We'll get 89 plus 49, which would give us the square root of 138. So that there represents the magnitude of vector FC. So that's the answer to part A. And then part B, they are asking, write an equation for the plane containing the points P, B, C, and D. So points P, B, C, and D, that's this plane over here. What's the equation of that plane going to be? Well, if you remember when we were discussing it before, we said that this face, point P, B, C, and D, it's always going to have a y value of 5. Right? That y value of 5 is constant for all points on that plane, right? Because that plane is sort of sticking out of the y-axis at 8.5. So we can actually relate this to the case where we had horizontal lines in the xy graph and the Cartesian plane. So if you remember, let's say we had a horizontal line at a y value of 5. So the y value of 5 was constant. So we had a line like this. It's sort of similar to that. notice how that y value of 5 is staying constant, and then the x values can really be anything. And what was the equation of that line? It was just y equals 5. The equation of any horizontal line in the 2D case is just y equals whatever that coordinate is, whatever that constant y value is. Well, same thing up here, just in 3D now. Notice the y value is always constant, so if you notice, all of these points on this face all have a y value of 5. It's the x and z coordinates that are always changing. Same thing here. Any coordinate that's on this line here, the y value is always 5. It's always the x values that are changing. So y value is consistent. It's the x and z coordinates that are always changing. So the equation of this plane here is same thing. It's just y equals 5. So it's just a plane that's sticking out at a y value of 5, and it's the x and z coordinates that are variable. They're always changing, and then that y value is always constant. So you could just write, like we did in the 2D case, y is equal to 5. That's the equation of the plane.